Alright, this is 8.1, and this is properties of parallelograms, and we're going to prove some of them. First thing, before we get into that, is we're going to talk about quadrilaterals. And if you remember that about quadrilaterals, you remember that it is a four-sided object, right? Like this one. And the sum of the interior angles of a four-sided object is 360 degrees. A quadrilateral can be a parallelogram. Well, parallelogram is a quadrilateral, but it's a special quadrilateral. Right, so if I have a quadrilateral, or parallelogram rather, there is two sides of this quadrilateral are congruent to each other. Okay, so the properties of a parallelogram are as follows. Okay, first, of a standard parallelogram, one, the opposite sides are congruent, meaning that this side is congruent to that side, and this side is congruent to this side. Two, the angles opposite each other. Angles opposite each other are congruent, right? So this angle and this angle and this angle and this angle are. This angle is congruent to this angle, and this angle is congruent to this angle. Okay. Number three, angles next to each other. Next to each other add up to 180 degrees. Right, a fancy way of saying that are consecutive interior angles are supplementary. Right? Consecutive meaning in a row, like a president can't have more than two consecutive terms in office, like two back-to-back terms in office, right? So these two angles here are consecutive, so like a single angle plus a double angle equals 180 degrees, and then those two combined equal 360. Right. Well, these two combined equal 180. Okay. And then the fourth one is if I connect the two similar angles, the two identical angles to each other, like this and like this, right? Those are called diagonals for diagonals of the diagonals bisect each other, meaning that they split each other in half. So this two line segments and these two line segments would be the same, right? And this line segment and this line segment would be the same. Okay, so those are the four different properties of a quadrilateral. So how do we prove that? Let's do some proving of some of this stuff. Right, so you have to kind of I'm just gonna walk this down a little bit. Okay, so do I have a light? Yeah, that's a light. Maybe I can make this a little brighter. Okay, so let me turn that this way. Right, so I have a parallelogram. I'll do it like this, I guess. One going this way, and one going this way, like this. Right, and then these two are connected like this. And I want to prove something like, and we'll call it, excuse me about that, we'll call this I'm going to pause for a second and close my door. Hold on. I'm going to call this quadrilateral or this parallelogram A, B, C, and D. And we'll say that the givens are that A and B are parallel to C and D, and that, okay, and that AC is parallel to B and D, and we are going to prove that the measure of A and D are congruent. That's what we need to prove. Okay? That's what we're trying to prove. Alright, well, the first thing is first you always rewrite the given statements, right? So AB is parallel to CD, and AC is parallel to BC. All right, well, how can we do this, right? Well, we know we want to be able to like make triangles that encompass these two angles, right? And I already have two sides of these. If I draw a line encompassing these two sides right here, or these two angles right here, I've made two triangles. I've made two triangles. What do I know about these two triangles? Well, if I know that these two triangles, it says this is a parallelogram, right? I know that too. I know that A, B, C, D is a parallelogram. Is a definition of a parallelogram. And if that's true, then I can say that AB is congruent to CD. Alright, so I can put little hash marks like that. Okay, and now I can say that 4, because this is a property, I can like put all this in one, I guess. AB is congruent to CD, and I'm also going to say that AC is congruent to BD. So these two are congruent, right? So, and this is because there's a property of a parallelogram. That's a short script parallelogram, right? So now I have shown that these two line segments that are opposite to each other are congruent. Alright, so this is all in number 3. So number 4 step is I drew line CB, and I'm going to say that line CB is congruent to itself. And anything that is congruent to itself is a reflexive property. Reflexive property. Okay, so a reflexive property. Now I can say that this is congruent to itself. Well, look what I've done. Right? I can now say that at number 5, I have two triangles that are congruent. I can say triangle, we'll say ABC is congruent to triangle DBC because of side, side, side congruence. And if that is true, now I can say that angle D, or right angle A, and angle D, and angle D are congruent because of corresponding parts of congruent triangles are congruent. Okay, so that is how you would solve this thing. I'm going to pause and get out an example from homework. Okay, so here is a question that gives us quadrilateral RNBG. and it tells us that Rn is congruent. Rn is congruent to GB. So those are congruent. And NRB is congruent to GBR. Okay, and so we need to prove that it's a parallelogram. So how do we do this? So one of the things that you can do to help with this is to look ahead and kind of work it backwards. Okay, so they are look ahead here and see where they get ahead to and where they work toward. Okay, so they get ahead here and they end up proving that RGB, so this triangle, and RNB are congruent. Okay, and then they move a little bit further, and they say that if two lines are intersected by a transversal, then these lines are parallel. So they're going to use this fact that some lines are parallel. Okay, so and then something happens, and then some more lines are parallel. So this step here is a pretty significant step. So let's see, and then we can figure out these angles. Something happens because of these angles here. Okay, so what is going on? So this says NRB. So I'm going to switch to blue, right? Because the blue is the not given stuff. So NRB. So angle NRB is, well, this was given, and so they split up the givens here. All right. So, well, the one thing that they kind of did and they showed here in the middle here was that this RB, how do they make these two triangles? Right? How do they make these two triangles? Well, they put in here line segment RB. They put in RB. So let's just state the obvious about that. RB is congruent to RB, right? And that is the reflexive property. Reflexive property of congruence. Okay, and now because that was given, and we have these triangles, we can say that we have triangles are congruent. Well, how can we say that? That we have this thing. So we have a side, an angle, and then another side, right? So we can say that these two triangles are congruent because of side, angle, side congruency. Okay, so now what else can we say about these two things? Well, how does that help us? All right, well, we can also say that if these are congruent, right, and this is a transversal, then the only way that that can exist is if these two lines are parallel, right? So RN is congruent or is parallel to GB, right? So that has to be true. Okay, so that's a little out of order, but that's okay. So there you go. Yeah, those were given to us. Okay, so now so we have to say that so we have these congruent triangles. So we can say that we have already proven that these are Rn and GB are parallel. So now we have to prove that these are parallel, RG and NB. So we need to somehow figure out about alternate interior angles of those. Okay, so what are the alternate interior angles of those? If we had BRG, okay, if this was a transversal, right, this would be an alternate interior angle, okay, and then RBN, also alternate interior angles, okay, so those would be the two there that we're working with. BRG, angle BRG, congruent to angle RBN, angle RBN, and how can we say that? Well, that's because the corresponding parts of congruent triangles are congruent. And so that is congruent to that. And if that is true, right, then two lines intersected by then the alternate interior angles are parallel. And so that makes this and this and this and this are parallel. All right. So then, if those two, then I can say that this is A, B, C, D. Well, that's not true. This is a typo. This is R, N, B, G is a parallelogram is because that is a definition of a parallelogram. Okay, so that is how you kind of walk through that's how you'll walk through one of these things. Look ahead, walk your way backwards, and figure out what they're trying to use, and that's how they kind of unravel. I hope that helps out.